I'm going to ask you to write this question down, stop the video and work it out. Then after that, you watch the video of my solution. Finished? Alright, so this is an example of a differential equation that can be solved by separating the variables. So you want to do your transposition and so on, so that you have a function of y dy on the left equal a function of x dx on the right, and then you integrate both sides. So let's see what happens here. If you divide by y minus 3, you're going to get x dy. No, don't divide by y minus 3. Divide by x, I should say. If you divide by x, you get y minus 3. X would cancel itself on the left. It would be equal to 4y over x. Alright, divide by y now. If you divide by y, this y would cancel itself and be under here. Multiply by dx now. So you have this dy equal 4 over x dx. So this is what you have. Y minus 3 over y dy equals 4 over x dx. Now, you want to find the integral of y. Well, y minus 3 over y. Same as y over y minus 3 over y. But y over y is 1. So, you find the integral of 1 minus 3 divided by y dy, and that is equal to 4 over x dx, the integral of 4 over x dx. But this can be written as 4 integral of 1 over x dx, so write it that way. 4 integral of 1 over x dx, right? The 4 integral of 1 over x dx. Now, this would be, well, you could expand the bracket. We could just do what is in the bracket, do the integration, but you could say also integral of 1 dy minus 3 integral of 1 over y dy equal 4 integral of 1 over x dx. Alright, we'll do that. So this becomes y, right? Integral of 1 dy is y minus 3 integral of 1 over y dy is ln y equals 4. The integral of 1 over x dx is ln x, and then plus c. Yeah, so we have this. But let's see if we can write it in a more concise manner. Let me see now, what would you do? So you have y minus 3 ln y. This can be written as y minus ln y to the power of 3 equal, well, you see the c? It can be written as ln of another constant. Say ln a. So when I say 4 ln x, well, this itself would be ln x to the 4th, right? Remember your indices. Now ln x to the 4th plus ln a is the same as ln x to the 4th times a. So let's write it like that. Y minus ln y cube equal ln ax to the fourth, right? So that's what we have. Now you got the solution already, you know. It's just that I want it to be in a more concise manner. Suppose you find e to the power of both sides. E to the y minus ln y cube equal e to the ln a x to the fourth. Now it would be same as e to the y over e to the ln y cube. Remember your rules of logarithm and indices too, is equal to e to the ln a x to the fourth, which would give you a x to the fourth, right? Alright, so what happens here? What's going to happen here? E to the ln y cube. You have e to the y over y cube equal a x to the fourth. Alright. So this now, how can you write it in another way? Suppose you multiply both sides by y cube. You get e to the y equal a x to the fourth y cube. Alright, so that's what you have. And then, well, you could leave it like that. But suppose you divide both sides by a. When you divide by a, you're going to have this over a cancels, and this over a. This is same as e to the y times 1 over a. 1 over a is a different constant, so we can call it b. b e to the y equals x to the fourth y cube. That looks interesting. Alright, but a quick review. You have x, y minus 3, dy by dx equal 4y. You want a function of y dy on the left equal a function of x dx on the right. So, what we'll do here, divide both sides by y to get the y on the left, multiply by dx to get the dx on the right, and then divide by x to get the x on the right. So we have y minus 3 over y dy equal 4 over x dx. And then this is fractions, so y over y is 1 minus 3 over y dy equals 4 times 1 over x dx. You didn't necessarily have to put the 4 outside the integral sign, but it's a bit easier to deal with when you remove those extra numbers from the integral, from the function you're going to integrate. So this isn't, I break this up into integral of y, integral of 1 dy minus 3 integral of y dy. You don't necessarily have to break this up. You could do the integration inside the bracket. So what we have is y minus 3 ln y equals 4 ln x plus a constant, which can be ln a, whatever a is, right? So we essentially solve it here, but we wanted to use our knowledge of logarithms and indices to put it in a more concise manner. Alright, but you follow your rules, your laws of indices and logs, and you end up here. Right? But you have a solution. You basically have a solution from up here. Right? Alright, so that is it for this video.